Assalamu alaikum warahmatullahi wabarakatuh. This is Miss Linda. We'll continue, inshallah, solving IB past paper questions. We reach question number 23 from the document. Here we have a circuit that shows a negative temperature coefficient, NTC, negative temperature coefficient, thermistors X, and a 100 kilo ohm fixed resistor connected across a battery. The battery has an electromotive force, 12 volt, and negligible resistance. Define the electromotive force. Now, first, before we define the electromotive force, what is a thermistor? Thermistor, it's a resistor that changes with the change of the temperature. So it is thermally sensitive resistor. One of the properties of this type of resistors is negative it's a negative temperature coefficient. Negative temperature coefficient, it means the thermistor exhibited a decrease in the temperature. So I will have a decrease in exhibited decrease in the electrical resistor, decrease in the electrical resistor when subjected to increase in temperature, okay, and vice versa. Okay, so what is the electromotive force? Electromotive force, or the voltage of the battery, epsilon, will equal work done over a unit charge. Work is joule per coulomb, joule per coulomb, or volts. Now here we have a relationship between the resistance of this thermistor and temperature. So as we increase the temperature, you see I have a decrease in the resistance, Determine the temperature of this resistor, X, when the potential difference across R is the fixed resistor, is 4.5 volt. 4.5 volt. So I need a temperature. How am I going to solve this question? I'm going to use circuit analysis. I know here there is a current that comes out of the circuit. And these two resistor R and X, they're connected in series. So the voltage across X plus the voltage across R should equal the voltage of the battery. So Vx plus Vr should equal 12. I don't have the voltage across the thermistor, but I know the voltage across the fixed resistor, which is 4.5, and this will give me 12. Take this to the other side. So the voltage across the thermistor will equal 12 minus 4.5. It will give me 7.5 volt. Now I'm going to use Kirchhoff's law. Here I have, this is the loop. So summation of voltage across this loop will equal 0. So I will have 12 minus the voltage across X minus the voltage across R. The voltage across R, since I have a value for the resistance, which is 100 kilo ohm or 10 to the power 5 ohm, I can say it's the current times this resistance R, which is 10 to the power 5. And I know the voltage across X. The voltage across X is 7.5. This will equal 0. So rearrange this equation. I will have a 12 minus 7.5 will equal 10 to the power 5 times I. 12 minus 7.5 is 4.5. Divide both sides by 10 to the power 5, so times 10 to the power negative 5 amps. This is the value of the current in the circuit. I have the current. I need now to find the value of this resistance R. So the value of the resistance R is the voltage across the resistance divided by the total current in the circuit. The voltage across the resistance is 7.5 divided by the current, it's 4.5 times 10 to the power negative 5. And this will give us 1.67 times 10 to the power 5 ohm. I can write it as this will equal 1.67 times 10 to the power 2 times 10 to the power 3 ohm, which will equal 167 kilo ohm. This is Rx. So I will go back to the graph, and the value 167 here. From here till here is 50. 50 divided by 5, 50 divided by 5, it will give me 10. Each square in the vertical direction will equal 10. So here I have 150, and here 160 is around 170. So it will be here, this one, 170. We'll go down and read the value of the temperature here. Now from here till here I have 10. 10 divided by 5, because I have 5 squares, it will give me 2. So each square in the vertical direction will give me 2. So this value here I have minus 40. So this value here is minus 38. So the temperature, what is the value? Determine the temperature of Rx is 167 kilo ohm, because here the unit is kilo, 167. The temperature will be negative 38 degrees Celsius. Okay, this is the first section of this question. Second section is state the range of temperature for which the change in the resistance of the thermistor is most sensitive to the change in temperature. So here it will start changing from negative 50, this value here, negative 50, and it will change dramatically till almost negative 30. You see, it's really steep graph. So it's between negative 50 degrees Celsius and negative 30 degrees Celsius. Triple I, state and explain the effect of a decrease in temperature on the ratio of voltage across the resistance R divided by the voltage across the resistance X over resistance R. We said if we have here the resistance will decrease if the temperature will increase and vice versa. So as we decrease the temperature, what will happen to the resistor? The resistor will increase. That means if I is the same, the voltage of X will increase. So here Vx divided by VR. If we increase the voltage of the thermistor, VR will decrease. So in general, this ratio, all of this ratio will what? Will increase. Okay, that's it. We'll continue, inshallah, the rest of topic 5 questions in the next videos.